Okay, so I'm going to go over what will be on your final. I'm going to do this pretty quickly because you probably don't need a lot of instruction. As long as you're doing and keeping up pace with the class, you should be fine. Each question has a lot of points attached to it, so I wanted to make sure there were multiple parts. So I picked particular questions that were like that. So you see that the first two rows are copied, right? But then the third row and the fourth row, you have to actually perform the indicated operations. So do be careful with that because it is very easy to make a mistake. So for instance, you are multiplying -6 to the first row, -6, and then +6. And then the last is going to give you a -12. And then you're adding it to the actual row 3, okay? And you're placing it into row 3. So just in case that causes any confusion, so 3 and 9, and then when you add that together, you're going to get 0, you're going to get -6, you're going to get 1, 9, and -3, and that is this row. So your job is to do the last row, okay? Multiple parts on this one as well. So you need to look at, and you can look at this as y equals x, f of x being equal, absolute value of x, my bad. And you're just going to do the transformation. So you know that this is moving to the right, this is moving up 6, and then this will stretch it by -2. So just be careful. And I mean, there's so many multiple parts to this, so just be careful when you get to this problem. And then, the properties of logarithms, there's addition. So you need to remember that even though we don't have a log base 10 written there, that it's there. And then 20 times 50 is 1,000. And then you have to remember that 10 to the third power is 1,000. So that's why you get 3. For this one, it's to determine whether the following statement makes sense or does not make sense. So it says, even if a linear system has a solution involving fractions, I can use graphs to determine if the solution set is reasonable. And it says the statement makes sense because a linear system with a solution set of exactly one real ordered pair has a graph of 2 lines intersecting at one point. For number 5, just has multiple parts. So the exponential function f with base b is defined as f of x equals b to the x. In your book, it might be also written as y equals b to the x. There are times when it's also written x equals b to the y. So just be mindful of that. And then using interval notation, we know that, when we have an exponential function, it is going in both directions forever, but the range is cut off unless we have any transformations where y is equal to 0. Oops, I put y is equal to x. I meant y is equal to 0. Y is equal to 0. We have long division here. So remember x plus 7, and then you divide it into x squared plus 11x plus 28. You remember x going into the first term, place it here. We got x squared, and then x times 7 is 7x. Change the signs and add. We get 4x plus 28. Same thing, we go x into 4x plus 4, 4x, 28. Change the signs, add, get 0, and there you go. For number 7, it is just like, or similar to number 1. Actually, it's just like it. I might change that one. I didn't realize I had 2 on there that were just like it. So you know what to do there. And then we have a function f of x equals 4x squared minus 4x. You just have multiple parts. So just keep in mind what your minimum and maximum value is. So it's either a maximum or minimum. You can tell that by the a value, and then your domain and range. For this one, just use the properties of logarithms. So you know when it's addition here, you just multiply. For this one, you're just adding the like terms. So 8 plus 7 is 15, and then negative 3i plus 8i is 5i. And then you just have some explanation here. So to solve a system of equations by substitution, first solve either of the equations for one variable in terms of the other. If one equation is in this form already, the step can be skipped. In this example, right, we have the two equations. The first equation is already in this form. The second equation, next, substitute the expression found in the previous example into the other equation. This will result in an equation in one variable. And in this example, substitute what you have here. What you have here into the second equation. So you see right here, the second equation. And then for this one, you are just going to be careful with, your order. So just be careful that your B matrix, you actually would do B minus 4A equals X. That's what I would do. And you can rewrite it as X equals B minus 4A. So just be careful with the order there. So you just multiply 4 times A and then B minus. So the matrix B minus 4 times A. The solution set is empty. And you know how to get the rest of that in. Okay, so for some unknown reason, the Zoom that I was creating just stopped. So B minus 4A. And that would be this matrix -5, 8, 3, -3, 6, and 6. So that's my B minus. I'm just going to mentally do the 4 times the other matrix. So 0. We'll say -4. Because it's just 4 right now. The minus is already outside. So I just like to be very careful, especially with the negatives. And then this would be 28, right? -16. And I have the answer there, so if I mess up, I'll be able to figure it out. So -5 minus 0 is -5. 8 plus 4 is 12. 3 minus 24 is -21. -3 minus 28 is -31. 6 plus 16 is 22. And 6 minus 0 is 6. And that is your result right here. All right, so if I were to use the addition method, I probably would multiply the second equation by -3. So I would have 6x minus 21y equals 28. And then I would end up with -6x plus 21y equals -21. And when I add those together, I get 0x plus 0y equals 7, and that is where this comes from. So the solution set is empty. It is inconsistent, and inconsistent means that there's no solution. So that's right here. And then those lines are parallel, means they have the same slope. You can always graph both of these on Desmos as well, just to get the picture of what it looks like. You're going to solve this system using the Gaussian elimination method. And you see that it is part C. So they don't have a 0 here, but they have zeros in underneath the ones. So and this one might be a little tricky, this one right here, but Gaussian elimination method, you're just obtaining the row echelon form, so you don't have to have zeros in all of those places. So you just work it out as best you can. The beginning matrix is 1, 3, 0, 1, 4, 1, 2, -1, -1, and then of course over here is 0, 1, and -1. So you just want to, you want to have your 0 here, a 0 here, and a 0 here. So you just work the problem until you have zeros in those spots, and then your result will be over here on the side. Remember, if you show your work and you upload it, then you'll be fine. And yes, this final is only 15 questions. So this is pretty self-explanatory. We're using the graph of, you remember this also can be considered y equals the absolute value of x. And then we're just shifting it over to the left by 5, moving it up by 2, and stretching it by -4, which as soon as you see a negative in front of anything like this, you know that it's flipped upside down. So you just have to be careful there. And of course, if you notice that you get it wrong, you can always upload a correction or your work shown of what you did, and you'll get partial credit. Alrighty. So you don't need luck as long as you plan to study and have things ready for all of your questions. You go over this video, you will be fine. As always, thank you for watching and taking your time out to pay attention to detail. And don't forget to please subscribe and to share, to like it. One or all three is fine. And then I'll see you next time.